Hi, I'm Elizabeth with Logicwalk. In the last lesson, we explored how the Logicwalk operating system represents a file system internally. Now we're going to see how the OS creates new folders and files, updates existing files, and deletes folders and files. Before we walk through each operation, let's briefly review how the Logicwalk OS interacts with the file system internally. As we learned in the previous lesson, each folder in the Logicwalk OS is represented as a map with two entries: a file map, which associates file names with their contents, and the folder map, which associates child folder names with their index. When the Logicwalk OS is given a file path, it always starts at the root folder and resolves the path one component at a time. At each step, the Logicwalk OS uses the folders map to look up the next folder's index and move to that location. Once the final folder is reached, the OS either creates, updates, or removes entries in the files or folders map. We'll use the same lookup and mapping process throughout the rest of the lesson as we examine how different file system operations work. Suppose we want to create a folder with the following path. Before creating the new folder, the OS first checks that all ancestor folders already exist. Ancestor folders are the folders that appear earlier in the file path and must already be present before a new folder can be created. In this case, the ancestor folders are the root folder and the documents folder. Once the Logicwalk OS locates these folders using their mapped index values, it proceeds with folder creation. The LWOS appends the new folder to the file system. Since the file system previously contained 4 folders, the new folder becomes the 5th entry and is assigned index 4. The LWOS then updates the document's folder's folder map by adding an entry that maps the name history to index 4. Next, let's see how the Logicwalk OS creates a new file. Suppose we want to create a file at the following path. The file contains the text shown on the screen. After resolving the file path and reaching the history folder, the Logicwalk OS adds a new entry to the folder's files map. The key is the file name, events.txt, and the value is the file's contents. At this point, the events text file becomes part of the file system and is stored inside the history folder. The Logicwalk OS can also update the contents of an existing file. Suppose we want to update this file so that it now contains a more precise value. After locating the math folder, the Logicwalk OS looks up the PyText file in the folder's files map. Instead of creating a new entry, the OS replaces the value associated with the existing key. The file name remains the same, but the file's contents are updated. Now let's see how the Logicwalk OS deletes a file. Suppose we want to remove this. After resolving the file path and reaching the documents folder, the Logicwalk OS deletes the file by removing the birthdays text file from the folder's files map. Once the entry is removed, the file no longer exists in the file system. Deleting folders is more complicated than deleting files. Suppose we want to delete this folder. The Photos folder does not contain any files or child folders. At first glance, it might seem reasonable for the Logicwalk OS to simply remove it. However, folders in the Logicwalk OS are referenced by their index values. If the OS were to remove the folder entirely, all folders stored after it would shift their index positions. This would break existing mappings in other folders that still reference the old index values. To avoid this problem, the OS removes the Photos entry from the root folder's folders map, but leaves the folder itself untouched internally. After this change, the Photos folder is no longer reachable from the root. From the user's perspective, the folder has been deleted. Folders that are no longer reachable are called orphan folders. To reduce wasted space, the OS may reuse orphan folders in the future. When a new folder is created, the LWOS can place it in one of these unused index locations instead of allocating a new one. Now let's look at what happens when we try to delete a non-empty folder. Suppose we want to delete this. The Documents folder contains files and child folders, and those child folders also contain files. If the OS were to remove only the Documents folder, all of its descendants would become unreachable. Because of this, most operating systems refuse to delete non-empty folders by default. If we explicitly choose to delete the folder and all of its contents, the OS must delete items from the bottom up. The Logicwalk OS first identifies all files and folders that descend from documents. It then deletes them using post-order traversal, meaning child files are deleted before their parent folders. By deleting the deepest items first and working upward, the OS ensures that no files remain reachable after their parent folders are removed. After this process is complete, the Documents folder and all of its descendants are no longer reachable from the root. In this lesson, we explored how the OS creates new files and folders, updates files, and deletes files and folders. In our next lesson, we'll explore where these folders actually live.